Hello, chemistry students. Today we are going to talk about ionization reactions with water and acids. So an ionization reaction is when an acid ionizes in water and it ionizes water to form hydronium ions, and hydronium is H3O+. Now we've been talking about acids dissociating in water and breaking up to make an H+ or a hydrogen ion. Well, what happens here is that H+ will react with the water, the H2O, and it forms hydronium, which is H3O+. So an example, we have HCl, hydrochloric acid, plus water, H2O, and the hydrogen ion from the acid HCl is going to react with the water to form H3O+. That is your hydronium ion, and then the Cl-. So let's write the ionization reaction for nitric acid, HNO3. So HNO3 plus water, we know that since it is an ionization reaction, it's going to ionize water, which means it's going to turn water into an ion. The H+ from nitric acid is going to react with the H2O to make H3O+ and NO3-. Now let's write the ionization reaction for sulfuric acid, and we are going to assume that both protons and the sulfuric acid, both of the H's, are going to be released. So we have H2SO4 plus H2O. Now we know that the H's from the H2SO4 are going to combine with the water to make H3O+, and then the SO4 is going to break off to make SO4- too. Now we need to balance this equation. We have two hydrogens over here, two hydrogens with the H2SO4, two hydrogens with the water, so that's a total of 4 hydrogens, but we only have 3 over on the product side for H3O. So we put a 2 in front of the H3O to make a 6 hydrogens, and now we need to fix this side over here. Now our SO4s are balanced, so I'm not going to put 2 in front of the H2SO4 because that will unbalance our SO4. I'll put 2 in front of the H2O, and that gives us 4 hydrogens here and 2 hydrogens over on the SO4, and 4 plus 2 is 6, so we are now balanced. Now dissociation reactions, we've already talked about this in the previous videos. Bases dissociate to form hydroxide ions. An example is sodium hydroxide will dissociate in water to form sodium and hydroxide. So we need to write the dissociation reaction for KOH, or potassium hydroxide. So KOH will dissociate in water or break apart into its ions to the positive ion, which is K+, and the OH ion, which is OH-. The dissociation reaction for calcium hydroxide, it will break up in water into its positive and negative pieces. The calcium breaks up into Ca2+, or +2, because it has 2 valence shell electrons and it's easier to lose 2 than gain 6. So lose 2, that's its oxidation number. And then OH-, and there are 2 hydroxide ions over on the reactant side, so we must have 2 hydroxide ions on the product side. Thanks for watching.